there, welcome. My name is Yijun Liu and I'm from Oxford College of Emory University. In this video, I will present my research in computer science that I did with my mentor, Dr. Yijun Liu, who's also from Oxford College of Emory University. I understand that this poster may be a bit difficult to see, so I posted a link to download my poster in the description box below. My topic is one-to-one and one-to-multiple user task mapping in task-dependent mobile crowd-sensing. So what is mobile crowd-sensing? Well, mobile crowd-sensing is basically using humans who are carrying mobile devices that have sensors in it to sense the world. What does that mean? So basically, I carry my smartphone around every day, and there are cameras and GPS in my smartphones that can be used as sensors. So I, as humans who are moving around with my smartphone, we together can form as a sensor to sense data in different locations. Some typical examples of mobile crowd-sensing include Google Maps that is recording live photos of different locations, or some researchers want to know the biodiversity in a region. So in mobile crowd-sensing, there are end users or companies or researchers who are publishing those tasks in different locations and request the users who are carrying the mobile devices to complete. So one of the fundamental questions in mobile crowd-sensing is how can we allocate those tasks to users with the consideration of the distance that each user travel, the number of tasks we are completing, and also the number of users we are hiring, because there are some costs associated with hiring users and the distance letting them to travel. So in my research specifically, I have separate two scenarios. The first one is one-to-one and user task mapping, and second is one-to-multiple user task mapping. One-to-one basically means that each user will be only allocated to one task, and one-to-multiple means that each user will be allocated to multiple tasks, depending on the nature of the research. In my research for one-to-one user task mapping, I use bipartite matching algorithms, and for one-to-multiple user task mapping, I use greedy algorithms. And I also run my simulation in a task-abundant scenario using the default data set. Task-abundant basically means that there are more tasks than users in that research. And it happens usually in rural areas where there are less population. The default data set is basically, it contains basically 15,000 of users' phone call records and their cell phone tower locations. So I know the time and locations of those users from those data sets. So basically my result shows that as the number of users increase, we can complete more tasks, and then as the number of tasks increase, we have a longer distance traveled. And also for the one-to-multiple user task mapping, we separate two different scenarios. The first scenario is that we are trying to minimize the total distance traveled for all users to complete all tasks. And second scenario is that we try to minimize the number of users while recruiting. And finally, we have a ratio between the trade-off of trying to minimize the number of users and try to minimize the total distance, so that in future practical scenarios, by applying those ratio, we can choose which algorithm is most suitable for that particular scenario. And also, finally, we did compare the task completeness rate among the one-to-one and one-to-multiple mapping algorithms. Definitely, one-to-one mapping has a lower task completeness rate because each user can only complete one task. But at the same time, it also has the lowest distance travel per user number. In conclusion, this research have developed algorithms for one-to-one and one-to-multiple user task mapping, and also compare the performance between the algorithms in the task-abandoned scenario. However, in this research, I only considered the task-abandoned scenario, but didn't consider the user-abandoned scenario. And also, in the simulation, I did not vary the time sensitivity of each task. So some future research is needed. Finally, I would like to thank to my mentor, Dr. Ting Li, for her instruction and help. And also would like to thank to Summer Oxford Research Scholars Program for providing its funding. And finally, thank you all for watching this video. If you have any further questions, please ask me in the Q&A session. And also, I will drop my email link in the description box. And hope you enjoy the rest of your Georgia undergraduate research symposium. Thank you so much.